Hey students, Mr. Ling here. Just wanted to go over surface area and volume again because I don't think the lesson did a real good job with either one as far as really highlighting how to calculate these. So I want to show you a couple things first. First of all, I found this cool little interactive website right here where you can take different rectangular prisms. You can look at triangular prisms. I think they've got, you can change this to be like, oh, you can change the colors. Haha, didn't know that. But anyways, I thought that you could do a pyramid. Oh, there we go, pyramids. You can do pyramids down here. But anyway, it's a great tool to be able to like move the object around and really see it from all different angles. And just a couple of things to note. First of all, here is a net of the prism. So if I was to basically, if this was a cardboard box and I was to unfold it, this is what it would look like. And you can play that and kind of see how it's folded together. You fold up the sides like that, and boom, all six sides come together to form that box. So a couple things to note is that, you know, with a prism like this, all these lines are parallel. So in other words, you know, this line here is parallel with this line here. This line here is parallel with this line here. That means that this edge and this edge are the same length. This edge and this edge are the same length. And if I flip that up here, that edge and that edge are the same length also. And this edge and this edge are the same length. So opposite lengths are the same. Okay, that edge is the same length as this edge as well. So you really end up with three faces. Oops, stay in one place there. Stop moving. There we go. You really end up with three sides that are the same as those three sides. Okay, I just kind of flipped it around. And if you look at the net, let me just unfold this again here for you. You can kind of see this right there. So in other words, say this is the bottom, okay? That is the same as this right here. This side is the same as this side, and that end is the same as that end, okay? So kind of keep that in mind. So when we're looking at surface area, again, the surface area is, we should define that here, surface area is the area of all sides of the object, right? Now it could be a rectangular prism, it could be a, I don't know, a cylinder. That's a little tricky, but you can get the surface area of a cylinder too. We'll do that probably in geometry in high school. But at any rate, so the surface area is the area of all sides. And again, this has six sides. There's one side there, two sides there, three sides there. And then on the back, I'll do those in red. There is this side. Let's do these the same. So one is 1 and 4 are the same. 2 and 5 are the same. And 3 and 6 are the same. Okay? So to calculate this, let's just say, these are the side numbers. I probably should have used letters, but let's just say, I'll use black here. Let's give some length. So let's say this is 11 inches in height. This is, let's say 5 inches in width. And we'll say this length here is 4 inches, okay? So this edge is 5. That means this edge is also 5. This edge is also 5. And this edge back here is also 5. This edge is 11, so that means this edge is 11. This edge back there is 11. And this edge over here is 11. And let's see, that's 4, so that means this edge is 4. This edge down here is 4. This edge right there is 4. Hopefully that makes sense to you. But I encourage you to go back to this website and play around with this shape, and you can kind of see what I'm talking about. And again, this is learner.org/interactives/geometry/prisms if you want to go there and check it out. All right, so to calculate the surface area, basically, let's just start doing the sides. So this front face here, side 1, is going to be area is just, length times width, or one side times the opposite side. So, or one side times the adjacent side, I should say. So we'll call this the length and the height, or you could call this the length and the width. It doesn't matter. It's just one side times the other side here, adjacent side. So number 1 would be 5 times 11, okay, which is 55. Side 2 would be right here. This is side 2. And then we said this was 4, also times 11. Right? Because side 2 also shares the same edge here, right? Basically the height of this prism. 4 times 11 is 44. And then we have side 3, which is the top here. And the top was going to be, we've got this edge here is 4, and this edge here is 5. And again, it doesn't matter which edge, because these are the same, and then these over here are the same as well. So we've got 4 times 5, which is 20. Now, we can add all these up, and we get, let's see, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 11. We get 119 units squared. I'm just going to say units squared. We haven't said what these units are. All right, now, we're not done, though, because that's side 1, 2, and 3. But again, side 4, 5, and 6 are the same, right? So 1 is equal to 4, 2 is equal to 5, and 3 is equal to 6. So we have the same area for those 4, 5, and 6. So we basically have 119 plus 119, or we can say 2 times 119. And that equals, let's see, well, that's round 120. You round up by 1, so 120 and 120 is 240. But I got to take my 2 off, so it would be 238. I'm doing some mental math here too. We'll practice. So 238, that is our surface area. Now, you can also look at it this way. You can look at it, let me scroll down just a little bit here, like this. What did we say? Well, we have side, let's see, we have 5 times 11 was side 1, okay, plus 4 times 11 was side 2, plus, because again, we're just adding these. We add each area together, right? The area of side 3 was 4 times 5, all right? And we've got double this. So I'm going to put this in extra parentheses here and times everything by 2. If we set it up like this, you'll get the same answer, okay? So that's one way to think about surface area. Now, volume is even easier. Volume, I'll just write that in red over to the side here. Volume is equal to the length times the width times the height. Or you could just say the 3 different dimensions, right? That's where we get the word 3D from. This object is in 3D. There's length, there's width or depth, and there's height, okay? So we just plug in those numbers here for volume. We get 5 times 4 times 11. So our length was 5, our width or depth is 4, and our height is 11. And that should be, let's see here, what's the best way to do this? 5 times 4 is 20. Well, 20 times 10 would be 200, plus one more 20 would be 220. So our volume is 220 whatever units, but cubed, right? Because we're multiplying 3 together. So this is 5 units times 4 units times 11 units. That's why